Hey everyone, so it is raining like crazy outside, so it is the perfect weather to snuggle up, get a mug of tea or something, and we're going to do some set theory. Okay, so today we are doing one of the most important concepts in set theory. It is the concept of the subset, okay? Very important, comes up a lot, so let's figure out what it means to be a subset.
So let's recap a little bit what we learned in the previous video. So we learned about the set roster notation that's symbolized by the curly brackets and listing all the elements of the set separated by commas. We also learned about the set builder notation. So that's symbolized by the vertical line, which means such that we have a variable on the left side of the vertical line and then a condition on the right side of the vertical line. So now I want to look at relationships between different sets. And maybe the most important relationship of all is the relationship subset. So we sometimes see the term subset used in daily conversation. So something like, a subset of people infected with coronavirus are asymptomatic. So let's deconstruct what that means exactly. So let's say this big circle represents people who have coronavirus. And then this smaller circle represents people who are asymptomatic. So if you are asymptomatic, you're inside the smaller circle, but that also means that you're inside the bigger circle. So what that's saying is that if you're asymptomatic, you still have coronavirus. So that's essentially what we mean when we say subset. So let's deconstruct this example using the set builder notation. So we represent this with the subset symbol. It looks like this sort of horseshoe shape with a horizontal line underneath it. So this is the symbol for subset. So people with asymptomatic coronavirus are a subset of people with coronavirus. So let's look at a more precise definition. So A is a subset of B. That means that every element of A is also an element of B. So if B is this circle here, then A is wholly contained within B and it's at least as small as B. Now remember from the last video, we could say something like, well, the smiley face is a member of the set A. We could also say something like, well, the frowny face is not a member of A. And we symbolize not a member by putting a diagonal line through the member symbol. So we can do the exact same thing with subsets. So we could say A is a subset of B, in which case we have this kind of situation here. We can also say A is not a subset of B. So that kind of situation, we'd have our set B, but now our A set will have at least one element which is outside B, which is not an element of B. So we've got some region of A which is outside B. Now, what does it mean to have this horizontal line here? So you'll notice we've got this horizontal line here in the subset symbol. So let's say we have the set A, B, and C, and we want to know, is it a subset of the set B, C, A? So we've got the set L and the set R, the set on the left, the set on the right. We know they're the same set because they contain the same members. But is L a subset of R is the question. And yes, it is. Why? Because every element of L is also an element of R. So even though these two things are the same set, L is a subset of R. Likewise, R is also a subset of L. So anytime we have two equivalent sets, they are subsets of each other. So the horizontal line, that's leaving open the possibility that the two sets are equivalent. So what if we get rid of the horizontal line? So the subset symbol without the horizontal line is called a proper subset. And what does that mean? It means the set on the right of the proper subset symbol has to have additional members that are in R but not in L. So let's look at a summary. Okay, so we've got three types of situations here. We've got L is a subset of R. that means that all the elements of L, all the elements of the set on the left, have to be in the set on the right, and the set on the right may or may not have additional members beyond the set on the left. So the horizontal line is leaving open the possibility that the two sets are equivalent. Okay, what about this one? L is not a subset of R. That must mean we've got this kind of situation here. So there are additional members of the set on the left not in the set on the right. So here the frowny face is in the left set but not in the right set. That means that L is not a subset of R. And finally, we've got L is a proper subset of R. So that means that L is a subset of R. So all the elements of L are also in R, and that's true. We've got all three faces here. But that R has additional members. So here R additionally has the frowny face. So this is a proper subset.
So that's basically it. That's what it means to be a subset. So subset means contained within. So you could say maybe the space in this apartment is a subset of the space in Sydney. So let's look at some examples and get really clear on the concept.
So we've got three sets, A, B, and C, and we want to know, are these statements true or false? Okay, let's look at the sets. So A is Z with this superscript positive sign. So Z means we're in the set of integers, and the positive sign means that we're only looking at the integers which are greater than 0. B is the set of positive integers such that they're between 1,000 and 2,000. And we're including 1,000 and 2,000 in this set because we've got these less than or equal to signs. Okay, so first off, is B a subset of A? Well, we know that all the elements of B have to come from the positive integers. That's what this symbol means here. So X comes from the set of positive integers, and A is the set of positive integers. So every element of B has to be from the set A. So that meets our definition for subset, so this statement is true. Okay, let's look at the next one. Is C a proper subset of A? So that means that A has to have additional members beyond the members C. Okay, so C is the set containing 1,000, 2,000, 3,000, 4,000, and 5,000. So all of those are positive integers. All of those are in the set A. So C is a subset of A. Now, is it a proper subset? If it's a proper subset, then A has to have additional members. So we know A has additional members. So A includes, for example, 1, 2, 3. All of those are in A, but not in C. So C is a proper subset of A, so this is true as well. Okay, is C a subset of B? Okay, so we know that C cannot be a subset of B because C contains 3,000, 4,000, and 5,000. Those are positive integers, but they don't fall within this specific interval here. So they don't meet the definition for being in the set B. We've got a kind of situation here where this is B. They do have some overlap, but there are elements in C which are not in B, namely 3,000, 4,000, and 5,000. So this one is false. Okay, the next one, is C a subset of C? Now, we don't even need to look at the definition for C because every set X is a subset of itself. Because any two equivalent sets are subsets of each other. So every set is always a subset of itself, so this is always true, no matter what C is. Okay, finally, is it true that B is not a subset of C? Okay, so if B is not a subset of C, it must have additional members not in C. So B contains any integer between 1,000 and 2,000, so it contains 1,001, 1,002, and so on. So these are in B, but not in C. So B cannot be a subset of C. So this is true as well. Okay, let's do one more of these. Choose the correct symbol. So the pitchfork, which we know is member, member of, and the horseshoe, which we know is subset. So let's look at the first one. Smiley, is Smiley a member or a subset of this set here? So we know it has to be a member of because it's contained within the set. It's an element of the set. It can't be a subset because the subset can only relate two sets to one another, not an element with a set. Okay, let's look at the next one. So is the set containing smiley, is it a member of or a subset of this set here? So it can't be a member of because the set containing smiley is not an element of this set. It has to be a subset because every element of the left set is also an element of the right set. Okay, next one. The set containing smiley, is it a member of or a subset of this set here? So it can't be a subset because that would mean that smiley has to be an element of this set here, which it isn't. But it is a member of because the set containing smiley is an element of the right set. So in this circumstance, it would be member of. Okay, last one. Is the set containing smiley, is it a member of or a subset of this set? So we can see it is a member of because the set containing smiley is an element of the right set. So member of is correct here. But it's also a subset. Every element of the left set, namely the smiley face, is also an element of the right set. So it would also be a subset. So either answer works here. So let's look at a slightly more complicated example. So we've got two sets here, A and B, and we want to know, is A a subset of B or is B a subset of A? Okay, so if we want to prove that A is a subset of B, so if you're in A, that means you're also in B. Okay, so let's look at some members of A. So to be in A, let's look at the definition. So x is an integer, and x is expressible as 20c plus 15, where c is also an integer. Okay, so let's say c is 0, for example. Then it would be 0 times 20 plus 15. We could do, c could be 1, so we could do 1 times 20 plus 15. C could be 2, so 2 times 20 plus 15, and so on. Okay, so let's have a look at what those values would be. So 0 times 20 plus 15, that's 15. 1 times 20 plus 15, that's 35. 2 times 20 plus 15, that's 55. Okay, and so on. Okay, so we can see that all the elements are multiples of 5. So that's going to be a big clue. So this is A. Let's look at B. Okay, so B is also from the integer set. And then a member of B, it has to be expressible as 5 times D, where D is some integer. Okay, so let's do the same process. Let's say D is 0. So we get 0 times 5, we get 1 times 5, we get 2 times 5, and so on. So this is going to work out to be the set of multiples of 5. So 0 times 5 is 0, 1 times 5 is 5, 2 times 5 is 10, and so on. Okay. So our question is A a subset of B? Now we can kind of eyeball it and see that all the elements of A are multiples of 5 and B is the set of multiples of 5. But let's try to work it out just a little more mathematically. Okay, so let's assume that we have some value x which is a member of A. Now that tells us that x meets this condition here, right? So x can be expressed as 20c plus 15, where c is some integer. Now let's assume, and just see how far it goes, let's see if we run into any contradictions, that A is a subset of B. That means that x meets the condition for membership of B, so x is expressible as 5d, where d is some integer. Okay, so that's from the definition of the set B. Okay, so let's look at this statement a little more closely. This statement 20c plus 15. Well, you can see that we can rewrite this. Let's factor out the 5, and we get 5 times 4c plus 3. Now we know that c is an integer, We also know that 4 times c is an integer because the product of two integers is also an integer. So if 4c is an integer, then 4c plus 3 is an integer because the sum of any two integers is an integer. So 4c plus 3 is an integer. So given that we can express 20c plus 15 as 5 times 4c plus 3, where 4c plus 3 is an integer, that means that we can express x as 5 times d, where d is an integer. We can plug in as the value of d 4c plus 3. And we know that 4c plus 3 is an integer, so it's true that x can be expressed as 5d, where d is some integer. That means that any value of x, if it's a member of A, then it can be expressed as 5d, which meets the condition of B. So for any x, if it's a member of A, it will also be a member of B. So this statement here is true. Okay, what about the second statement? So if B is a subset of A, then every element of B has to be a member of A. So to disprove this statement, all we need to do is find an element of B which is not an element of A. So let's try 5, for example. So 5 is an element of B because we can express it as 5 times D, where D is some integer. So for example, if D is 1, so 5 is in B, but is 5 in A? So is 5 in A? Well, that means we can express it as 20c plus 15, where c is some integer. So let's play around with it. Let's subtract 15 from both sides. So we get -10 equals 20c. Okay, and let's divide both sides by 20. So we get -10 over 20 equals c. -10 over 20 is -0.5. c equals -0.5. So if x is 5, then c equals -0.5. So -0.5 is not an integer, so 5 is not in A. So 5 is in B, but 5 is not in A. That means that B is not a subset of A, because there are elements of B which are not in A. So is B a subset of A? False.
So we did two very important things there. So the first thing we did was we wanted to prove whether A is a subset of B. And to do that, we made sure that if we got an arbitrary member of A, it would also meet the condition for membership in B. So anytime something meets the condition of A, it also meets the condition of B, and then we've proved that A is a subset of B. The other thing we did is that we proved that B was not a subset of A. And how do we do that? We found a single member, we just needed one example of something that meets the condition for B but doesn't meet the condition for A. So in that kind of situation, B cannot be a subset of A. So we proved that B wasn't a subset of A. So here's an example for you. See if you can perform the same kind of reasoning on this example.
So we have two sets. We have A and B. A is the set of integers x, such that x is expressible as 10c, where c is some integer. Okay, and let's look at B. So B is the set of integers y, such that y is expressible as 10d plus 10, where d is some integer. Okay, so we've got two different sets here. We want to work out, is A a subset of B or is B a subset of A?
So that's it from me. Thank you so much for watching. The rain hasn't really cleared up, so I'm gonna go snuggle under a blanket, watch some Netflix, and I will see you next time. Thanks for watching, everyone. Please remember to like, subscribe, hit the notification bell, support the channel so I can continue bringing you more great content.